Bonjour, welcome to Wahsa Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am the teacher Bronwyn Slade. This lesson is pre-recorded, so unfortunately you cannot join live today, but usually you can join live and call us at the Wahsa studio at 1-800-465-7144 or 737-4017. Then you're welcome to ask questions and have a conversation with me over the phone if you'd like. You can listen on the radio at 91.9 FM and also on the television at Bell Express U channel 972. You are also always welcome to join me live through the Zoom link when our lessons are live, and then you can see both the visuals that I am sharing as well as hear the audio and ask me questions if you have them. So how do you actually join a Zoom class? The link is available both from me, your teacher, and also your DEC. And that link, you just click on the link. And then once it prompts you, if you've opened it through a browser, it might ask you to launch the application, or if you've opened through the Zoom app, then it'll just give you joining with this course code or this link. Then you click join with computer audio, and then it will say the class will be recorded. Click got it. And then on the bottom left side of the screen, this is where your microphone and your video icons are, so you can turn them on and off. When they have the red line across them, they're turned off. So I ask that you have your video and your audio off, your microphone off, just so that we don't have so much information coming in. If you have a question, turn your microphone on and ask a question. That's totally fine, but it just keeps the Zoom a little bit easier to function if we don't all have our videos on. And then if you keep yourself on mute while you are not asking a question, then all of the noise that is in your life isn't broadcasted over the radio and recorded in our Zoom class. So just best to keep yourself on mute until you have a question to ask. Then to leave at the end of class, you click end, which is on the bottom right of the screen. And then if you need to take a pause or something during the break or during class, you need to run and do something else, you don't need to actually leave the class. You can just leave yourself on mute and with your video off, and we don't know that you're actually no longer at your screen, so that's totally fine. However, if you do end and leave the class, you can always rejoin it if class is still running. With Zoom, we have the option to have subtitles, in case that is something that is helpful. I do speak quickly and Zoom doesn't always pick up what I'm saying. I'm working on slowing down and enunciating, but I always have lots to pack in, so that is an issue that we have. But if you click on, you might have, it might just say transcripts, or you might have to go to view more and then up to hide subtitles. There might even say hide subtitles or show subtitles, and you can do whatever makes the most sense for you. All right, so that's how you use Zoom. But just on a question that I often come across is, what's the difference between the radio Zoom courses and the IEL courses, the independent learning courses? So first, I just want to run through how they are the same. The course materials, the evaluations, and the resources are all the same. Doesn't matter which one you're registered in, you have access to the same support and the same materials for both courses, for both versions of the course. The course is the same course. Anyone could listen and participate in the radio Zoom class. You don't have to be registered in it. If you are registered in the IEL course and you want to participate, you want to listen to the radio Zoom classes, that is totally fine. And all of our lessons are recorded, and I post them to YouTube shortly after airing, and everyone has access to that. So it doesn't matter if you're registered in the radio Zoom class, great, you can access them there. If you're registered in the independent learning course, you can access them there. That is open to anybody. It's available for anyone who has an internet and YouTube connection. So then how are they different? Basically, it's just about the schedule. So the radio Zoom in our program has a schedule of 4 terms per year, and the classes run for 9 weeks. During these sessions, I explain course concepts and show examples working through all of the 20 course lessons. So I'm giving you direct instruction for each of those lessons. And if you want to follow along, you can work along with me at that pace. The IL courses are open at the start to finish anytime. You can pick it up at any time, and you can finish it at any time on your own pace. You don't have to follow along with my pace through the Radio Zoom timeline. The only restriction is that we start at the beginning of the year, September. So this year, September 6th, 2022, and we end in the middle of June. June 16th, 2023 is our last day of the IL courses, which technically is the last day of the Radio Zooms things to be available as well, though all of those courses will be done by then. So our Radio Zoom schedule, just so that you know, is our MBF3C, our class, is scheduled Monday through Thursday from 2 till 3 in the afternoon. Friday, we don't have any classes scheduled, though we do work. You can reach out and connect. It's a good day to try to connect directly with your teachers. And as I said, our class is 9 weeks long, and we are starting first day, so our first week of our overall 9-week course. So just so you know what work you're going to need to submit for marking, the support questions in your booklet have a little pencil icon, and these ones are practice problems. They are not for marking. You decide which ones and how many to do. If you are understanding the concept, feel free to skip. You don't have to do the questions just because they are there. They are there to help you and support you. But if you're finding that it feels like a waste of time and you're really getting comfortable and confident with your answers and you're checking them in the back of your booklet and you're understanding your concepts, you're feeling really great with them, you don't need to do all the practice problems. That is okay for you to skip them if you feel that is right for you. However, on the flip side, if you're still really struggling with something and you need more practice, please ask, and I'm happy to send you more practice to make sure that you are understanding these concepts. The key questions, the ones with the little key icon, these are the ones that are the mark questions. So these are the ones that you need to submit for grading. So these ones, you need to do all of these questions. I'm marking all of them. You need to do them all. If you need to skip one to continue and come back, ask me a question about it, that's fine. But you need to hand all of them in so I can give you marks for all of your work. I also strongly encourage you to show all of your work, all of your steps, all of your thinking. This way I can understand what it is that you understand. If it is not working for you, if you're making a common mistake, I can figure out if you show me your work, I generally can figure out if you are making a mistake that is a calculation error. Do you have a misunderstanding about adding and subtracting negatives? Common mistake. People always make mistakes with those. They're confusing. Or do you not understand the actual content that you're learning, the new concepts? So if you just give me the answer, if you just give me one number at the end, there's no way for me to know where you made a mistake. All I can tell you is that it's right or wrong. You either get all the marks or none of the marks. If you show me your work, I can go through and I can figure out how I can support you, how I can improve your understanding. And I generally only take off part marks because most likely you have parts of the answer correct. You might not, but most of the time you have some understanding and I can give you some credit for that. So I strongly encourage you to hand in all of your work. Show me all of your work, please. So how do you actually submit your work for marking? So the first method is to scan and send your work in electronically. Oh, there's 3 methods. This is the first one. So you scan your completed work. If you have a device, most of us don't have scanners, but if you have a device, an Apple device has the Notes app, and it has a scan function. Android devices come with a Google Drive app, and it has a scan function. Both these are free apps that generally come with these devices, though you can download them, again, for free. If you need support on how to actually do those things, how to actually scan, there are some videos, some tech tutorial videos in my YouTube channel that I will link in the show notes and here, so that you can go and learn how to do that, and then you can scan your work in and send it to me. Then you can send it to me either by email to studentwork@nnec.on.ca and CC it to me at bronwyn.slate@nnec.on.ca. Or you can also send it to me through Facebook Messenger, where my name is B. Slate Wahsa. You just click on the little icon that says attach. It's like a paperclip, I think. And then you can attach a file and just send it to me through there. Either way is totally fine. There's not a preferred method for me. Whatever works easiest for you is totally fine. So just a note about why I prefer you to scan over taking a picture. If you need to take a picture, it's okay. You can do that. But when you scan with an app on your phone or just with an actual scanner, it means that it's easier to create one file with all of the pages, so we don't end up losing or missing a page. It is faster because it simplifies the image. The tech does something to it. We don't need to go into that, but it just simplifies it. It makes it easier to send, and it's a smaller file, which is easier to send. So if you are dealing with data or with sketchy internet, as many of us have to deal with, having a smaller file makes it a lot easier to send that and faster, so you don't take up as much of your bandwidth. Whereas taking a picture, it's a bigger file, it's more detailed. So I strongly encourage you to figure out how to scan if this is the way that you want to do it instead of taking pictures. If you can't, if you don't have these devices, you don't have access to a scanner and you just need to take a picture, that's okay. I can deal with it. It's totally fine. I'm just trying to make your life easier if scanning is a possibility. If you want to learn how to scan with your smartphone, if you have a smart device, let me know and I can help. So I can direct you again to those tech tutorials, or I can walk you through it if you need more support. Please just reach out. All right, so the second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at our location, 74 Front Street. We are the bright red building next to the post office here in Sioux Lookout, and we have a small white mailbox next to our side entrance. We are not yet open to the public. That may be happening soon, and then you can come in and drop it off. But for now, just 24 hours, 7 days a week, drop it in that mailbox, and we will get it and get it back to you as soon as we can. Then the third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students are also welcome to fax in their work. If you have access to a fax machine, that is totally no problem at all. So if you want to connect with me through social media, both my Facebook profile and my YouTube channel under the name B. Slate Wahsa. B. Slate is all one word with a capital B and a capital S. That's my name, and then Wahsa to acknowledge that it's a Wahsa account. If you friend me on Facebook or subscribe to my YouTube channel, you'll get notifications every time I upload one of our radio Zoom classes. So all of our radio Zoom classes are recorded, and then I post them to YouTube shortly after airing. I put them under a playlist called MBF3C. So all of our stuff is there. Then there's also tech tutorials and some other short videos explaining common errors or confusing concepts. They're all there on my channel under the playlist MBF3C, so that you can find any supports that I have available so far there. I do new videos and I upload them if there's a new concept that people are struggling with. And if you have something you want me to specifically ask for, I'm happy to do a video and upload it there as well. So it's a really good place to check online if you are outside of hours and you can't ask me directly for help and you need help. It's a good place to go so that you can see if there's anything there that can help me, help you, opposed to just doing a general internet search. Math is a really visual subject. I work really, really hard to connect these abstract concepts of numbers and symbols to visual concrete examples. So I really, really strongly encourage you to access the videos. Either join me live through Zoom and watch. You don't have to talk to me. You don't have to ask questions. You can just watch. That's totally fine. Or you can watch the replays on YouTube on your own time, which is a great option because then you can pause things, stop them, do some practice problems, come back to it later when you have more time, revisit things, watch them a couple of times. I've had students screenshot parts and send them to me to ask for more clarification so we know exactly what it is that you're asking about. The YouTube videos are just a great resource to access because you get the full experience. So I strongly encourage you to access them if you can. If you don't have reliable internet and you can't do either the Zoom option or connect to YouTube consistently, let me know and I'm happy to send you a copy of the recordings so that you get the full experience and you really can set yourself up for success. So if you have any questions or concerns, please reach out and contact me. I'm here to support you. This is my job. This is why I'm here. So you can email me, and my email address is my name, bronwyn.slate, and that's spelled BRONWYN.SLATE@nnec.on.ca. You can connect with me through Facebook, where my name is bslate Wahsa. You can call me at the office at 807-737-1488. My extension is 2209, or you can also call toll free at 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 3 p.m. So you can reach out to me during that time. Of course, I'm teaching from 2 to 3 for our class. So not available in those moments, but reach out to me. And if you need support and cannot connect with me during that time, let me know and we can try to figure out something that works for both of us. All right, let's dive into our lesson. I won't usually spend that much time setting up, going over the beginning of our course. This is our first day. I wanted to set it up pretty well. So lesson 1 in your IEL booklet in our course is transformation of quadratic functions. So our learning goals for our lesson are that at the end of this lesson, you will be able to recognize the important parts of a quadratic graph, specifically when it represents a real life situation. You will understand how A, H, and K change a quadratic graph, which is called a parabola. It's totally fine if that doesn't make any sense to you right now. Excuse me. Okay, you know you've met the learning goals because you can find the A, H, and K values in a quadratic equation. You know where they are, and you can explain the difference between a vertical reflection, a horizontal shift, and a vertical shift. Again, okay, if that doesn't make any sense to you now, but at the end of the class, those are the things that need to make sense. And if they don't make sense by the end of the class, then we need to go back and look at things again. So the most common question I get as a math teacher is, when will I use this in real life? And I want to say that today and our course overall, we're strengthening our understanding of connections and seeing patterns. So you may not need to be able to find the A, H, and K values of a quadratic equation in your real life. Most likely you won't. It's true. But understanding connections and seeing patterns in your life, that's definitely something that's going to come up. So though it's not directly related to this mathematical concept, we're using this mathematical concept to strengthen this transferable skill that is something that you can use in various places in your life. But first, we're going to activate your brain with some mental math. You may remember math mad minutes where students all had to sit in their rows in their desks and you've got a paper in front of you and most likely a pencil, and there was a timer up on the board, or the teacher had a timer, and you had 1 minute to do as many math facts as you could filling out of the paper. And they might have been multiplication facts, they might have been addition or subtraction, division, generally arithmetic facts, where you just had to do as many as you possibly could in a minute, and then you were graded on your how good at math you were. Well, I don't believe that that is a good strategy. This is not something that actually teaches students math skills and does not build confidence or comfort with math. So, over our course, instead of focusing on that as a useful tool, we develop strategies where you think and you use logic that make sense to you. You find friendly numbers that are friendly for you. There are multiple ways to figure out the answers to these problems, and that's all fine. And we're not having to do it fast. We don't have to have it memorized. We're just trying to understand and make connections. So we're going to do this, a mental math activity or question at the beginning of each of our lessons in order to strengthen our comfort and our confidence with our numbers. So our question today is 17 plus 4. And we're going to use a strategy of friendly numbers. And what I mean by friendly numbers are numbers that feel friendly to you. Each of us might have different numbers that are friendly, but there's probably a few that are fairly consistent in terms of friendly. So often things that end with a 5, so have 5 in the ones column, or 5 ones, or have 0 ones. And so with something like 10, 20, 30 ends with a 0. Those generally are friendly numbers that make our life a little bit easier to deal with. So this question, 17 plus 4, when I look at it, and that 7 and that 4 I need to add together, and they're not super friendly. I could count on my fingers, totally fine. Counting on your fingers is a great way to do it. It's a great strategy to use. It makes your brain light up. It actually, brain science has shown us that makes connections using your fingers, counting on your fingers, highlights more activity. It makes your brain think really well and make connections. So it's great. So what I'm going to think about in order to make my friendly numbers is I'm going to look at this 17, and I really want that to be closer. I'm going to think if it was 20, then that would be friendlier for me. So I'm going to break my 4 into a 3 and a 1, because 3 plus 1 is 4, sorry. And then if I do 17 plus 3, 17 plus 3 is 20. I know that 7 plus 3 gives me 10, so 17 plus 3 is going to give me 20. And now I can just add that 1, and I get 21. So that was pretty easy for me by breaking my numbers up into friendly amounts. Things that I was comfortable and confident with made it pretty easy to add that 17 plus 4. This is a simple example where we could have just counted our fingers. It's not very much, but it's something that we're going to use again later on, this idea of making numbers that are friendly for us. All right, so then before we dive into our new concepts, we just need to sort of think about what learning we've done before. And I want us to remember linear graphs. This is something that would have shown up in your grade 9 and your grade 10 courses a little bit. We're not going to spend very much time really in this course on linear graphs, but we just want to remember them. So linear graphs are this idea that if we're moving at a constant, a consistent, the same rate, then we get a straight line if we were to graph it. So here we have a little person on a roller coaster, and we see that if their roller coaster drops 225 feet over a short distance of 75 feet, this is a very steep roller coaster. And this person, you can see, is going really, really fast. However, if we have a second roller coaster that drops at a rate of 300 feet, a distance of 300 feet over 300 feet, that roller coaster is not so steep. The steepness of our line has decreased. And then thirdly, if we have a roller coaster that drops only 100 feet over 250 50 feet, then this roller coaster is much more shallower. We can see that this line is much less steep. So in linear graphs, we talked a lot about this idea of slope, where we were comparing the rise, how much we go up or down, and the run, how much we go over, and how that affects the steepness of our line. So we would have put this into a formula, which is y equals mx plus b, where m, our number here, is the slope or the rate of the change. So how fast our line, how steep our line is, how fast our roller coaster is. And b is our starting point, which is our y-intercept, which when we graph it is this point here, here on where it crosses our y-axis. So this should all be something that is kind of familiar, and how we can have an equation like y equals mx plus b, and how that changes our line. That it, as we change, here I will show you, this link will work. So we can see here, we have a rise of 5, a run of 8, and a starting point of 3. So if I change this, my line can get less steep or more steep, and our numbers change, our m changes. And if I move this dot here, our starting point changes, which potentially could change our steepness of our line, not necessarily, depending on the situation. And so as we move that information around, our equation changes. And so that's what we kind of want to think about today, is that when we're moving our parabolas around, is this idea that as we move things around, as our situation changes, our equation and our picture changes together. I will put a link into our show notes of the YouTube so that you can go and check that out if you want to play around with that. Okay, so that's what we just sort of need to remember, that idea of how we manipulated lines in the past. And now we need to dive into our new concepts. So parabolas are all around us. When we talk about quadratic equations, parabolas are the picture that we see. So it's this line that arches. So here on this basketball player is shooting this basketball, and it's following the pathway of a parabola. So it goes up, it goes to a highest point, and then it comes down at the same rate. So it like goes up and it slows down, and then it goes faster and faster and faster, and it has this symmetrical shape. This shows up in various other places. Here we have a water fountain. You can see this arching shape, and even here at a drinking water fountain, this going up and then coming down. But also, not just with movement, but in our structures. So swings have a parabola shape, this U shape or V shape kind of. Archways have a parabola shape. This bridge has the support systems are in place. They have, this is the parabola shape here. We go up and then come down, and then go up and then come down. And even a banana has a parabola shape, just to sort of see that parabolas are everywhere around us. So back to when we were looking at linear graphs, we talked about how y equals mx plus b is sort of it's called the parent function. It's sort of the general idea. So for a parabola, the parent function is y equals x squared. And that's sort of our base, where we're starting from, and everything all of our other parabolas, all of our other quadratics come based off of this simple idea of y equals x squared. So what this actually means, if we can, using a table of values so that we can see what this actually means when we're talking about y equals x squared. If we pick an x value and then we square it, we can figure out a corresponding y value. We can find a relationship between these two numbers. So if we pick 0 and we do, so x is equal to 0, 0 squared is 0 times 0, and so that is also 0. If we pick 1, 1 squared is equal to 1. If our x is equal to 2, then 2 squared is equal to 2 times 2, so that equals 4, so our y equals 4. 3, so our x value is 3, our y value is 3 squared, which is equal to 9. And 4 is our x value, then 4 squared is equal to 16. So with the table of values, we can pick any values of x, and we can figure out the relating y. We can also use negative numbers. So if I pick x equals -1, then -1 squared is equal to 1. -1 times -1 is equal to +1. So it's important to know our multiplication of our positives and negatives for this course, something that really comes up a lot. -2 is -2 squared is +4. -3 is our x, our y is equal to -3 squared, which is 9. And -4, our y is equal to -4 squared, which is 16. So you'll see a pattern in our numbers is that it's symmetrical around 0. So both 1 and -1 is +1. 2 and -2 are both +4. 3 and -3 are both +9. 4 and -4 is both +16. And that pattern is going to continue. And when we plot those points, we plot them on our graph, and then draw a line through them, we can see that this U parabola shape is developed by that pattern of squaring our x values. So that is our parent function. This shape that we're seeing here, where it's our U shape is symmetrical around the y-axis. So it's the same on both sides of the y-axis. It's like a mirror is down the middle. It's all above the x-axis. It's all opening up, and it goes right through 0, 0. The vertex, the very tip of our parabola, sits at 0, 0, right at our origin. So the general form of this of this shape, is y equals a times x minus h, and this we then say quantity squared. So x minus h inside this brackets is all squared plus k. Now that really doesn't make a lot of sense because this is just our general form. So then we can change these a, h, and k values and get various different parabolas. So for our parent function, our a is equal to 1, our h is equal to 0, and our k is equal to 0. So we put that into our general formula. A we replace with 1, h we replace with 0, and k we replace with 0. Well, x take away 0 is just x. X squared we can't do anything with because x we don't know what it is. It's one of our variables. 1 times that is just going to be x squared. And then we add 0, just means that it's going to be x squared. So that's how we get y equals x squared as our parent function, because we're not changing any of these values. These are sort of our baseline values, our invisible numbers. We don't show up here. We don't put a 1 in front of the x squared. If there's no number there, we assume that it's 1 because 1 times this number just gives us that number. So let's understand a little bit more what we are talking about. Sorry about my cough. So if we're trying to understand y equals x squared, let's look at a concrete example. So x represents the side length of a square. That's what, when we say x squared, that's why we say x squared, is that we are saying a side length of a square. So we have a square, and the length of each side is x. So then y represents the area of that square. So we're comparing the side length of a square to the area of that square, which is equal to, if you remember, the area of a square is equal to your side times your side. So x times x is x squared. So that's what this relationship is, the same idea. This is a concrete way of looking at this relationship of comparing the side length to the area of a square. So let's look at that a little bit more. Remember that x is our side length and y is our area. So if we have x a side length of 0, then our area is 0. I have this sort of phantom square here because there's no actual square there, because 0 times 0 is 0. So if we have a side length of 0, we don't have any area. That makes sense. So in our table of values, we have 0 and 0. If we have a side length of 1, well, our square having a side length of 1 and 1 means that our area is a total of 1 unit. So y equals 1 as well. If we have a side length of 2, x equals 2, then our area now is 2 times 2. So we can see that we now have 4 as our total area. If we have a side length of 3, we can see that our area of our square is 3 times 3. And so that means that we have a total area of 9. And if we have a side length of 4, we can see that 4 times 4 is equal to a total area of 16. Now, the pattern continues with if we were to have negative values for x, if we had a side length of a negative value, but that's not something that really makes sense to us, so we're not going to go there. We're just going to trust that if we extend this with this pattern is the same idea. With when we're looking at this concrete example, we're only going to be looking at positive values. So here on our graph, we can see if we plot these, our x and our y's, we can say 0, 0 is a point, 1, 1 is a point, 2, 4 is a point, 3, 9 is a point, and 4, 16 is a point. And if we connect those on our curve, we can see we have this half of our parabola shape. That would be reflected the same if we had negative values, but again, remember, we're only thinking about positive values for this concrete example. So that is how our parabola, the idea of comparing our side length to our area, is the basis of this relationship shape. So with math, one of the basic principles of math is looking at something and then asking, but what if we do this? What if we do that? And that's how many things get developed in mathematics, is that somebody thinks about something and figures something out, and then they or other people ask, but what if we do this? What if we do that? And so we are going to look and say, but what if we manipulate the situation and change something? What happens? So this, we're going to examine the k, and we're going to see if we manipulate the k, what happens. Now this is on page 5 of your IL booklet. Your IL booklet starts with A and then does H and then does K. And to me, it makes more sense to look at K and understand that first, and then understand H, and then understand A. So I'm going backwards compared to what your booklet does in this lesson. If you're watching this whole lesson before you do any of it, it's all good. Doesn't matter. You don't have to do in that order. But just to know that we're looking at K first, and this is on page 5 of your IL booklet. So if we're asking what if, we're saying, well, what if we add a number after we square the sides? How does that change the pattern? So we're doing the same idea, but we're going to still square our x is still our side length, y is still our area, but we're going to add a unit to it. And we're just going to use the example of 1. We didn't have to use the example of 1, but just keep our numbers simple. I'm using the example of 1. So we are going to Our h is still 0. Our a is still 1. We're not changing those. We're just changing our k because we're just going to look at our k, and we're going to look at this example if our k was 1. So if our side length is 0, and that means our area is for that is still 0, but then we're adding 1 unit afterwards. That's what this means, is that we put in a side length of 0, we square it, our area is 0, but then we're adding 1 more. So here, when x equals 0, y equals 1, because we added this 1 extra unit. Now, if we have a side length is equal to 1, now we have an area of equal to 1, plus we're still adding that extra 1. So now we have a total of 2. So when x equals 1, y equals 2. If x is equal to 2, our side length is equal to 2. So our original area is 2 times 2, 2 squared, which is 4, plus 1, because we have that extra piece that we are adding in. So when x is equal to 2, y is equal to 5, because 4 plus 1 equals 5. And we continue this idea with, if x is equal to 3, our side length is 3. That means our area is 9. 3 squared is 9. Plus 1 means we have a total area of 10. So when x equals 3, y equals 10. When x equals 4, we have a total area of 16. 4 squared is 16, plus this other 1 that we still have. So when x equals 4, y equals 17. So our pattern has shifted. Our x values are still the same. We pick the same ones, but our other values have changed. They've shifted, they've moved, they've increased by 1 because we added 1 each time. So if we were to graph that, we can see that this y equals x squared is still our parent function, this black one, but this red function, y equals x squared plus 2, was our new function that we were investigating, and we can see that each of our points have now shifted up 1. So our whole parabola has shifted up because we added 1 to it. Okay, so what if we subtract after we square the sides? How does that change the pattern? So now we're going to do x squared minus 1. How does that make it different? So if x is equal to 0, we have a 0 side length. So our original area is 0 squared, so that's 0. But then we're subtracting 1, so we're taking 1 away. So that means if we have 0 take away 1 is negative 1. So when x is equal to 0, y is equal to negative 1. When x is equal to 1, our side length is 1. So our area is 1, but we're subtracting 1. So 1 take away 1 is 0. So now we have x equals 1 and y equals 0. When x equals 2, when our side length is 2, then we see that our square, 2 times 2 is 4. 2 squared is 4. Minus 1, so we're subtracting that 1 off. So that means that we have 4 take away 1, which is 3. So when x equals to 2, y equals 3. When x equals 3, we have 3 squared, which is 9, but then we're taking that 1 away. So we take 1 away, and so we're left with 8. So when x equals 3, y equals 8. And then when x equals 4, our side length is 4, our area of our square is 16. 4 squared is 16. Take away the 1, so we're left with 15. So when x equals 4, y equals 15. So again, our pattern, our x's are the same, we pick the same values, but our y values have all decreased by 1 because we subtracted 1. So if we were to graph that, our black one is our parent function, y equals x squared, but we can see each of our points have now shifted down for this green line, y equals x squared minus 1. All of our points have shifted, and we still have that parabola shape, but it's all been shifted down. So we could go through and we could do all of the numbers in the world, but that would be a lot. So instead, we're going to look at this GeoBra little application where we can see that here, if we change our k value, remember a is still equal to 1, h is still equal to 0. If we change our k value, then this changes our whole function. So if we increase our k value, we make it a bigger number. We're going to go up to 3.5. So k is now 3.5. Our equation is y equals x squared plus 3.5. And we can see our whole parabola has shifted up. Every point has moved up 3.5. And it looks a little bit funny because here it looks like they're getting closer, but remember we're comparing it down along these vertical lines. So this point here has moved all the way up here. It's shifted all the way up. So our whole parabola shifts up by 3.5. So k equals 3.5. That means our parabola moves up 3.5. If our k value is negative, if I go down here and I go all the way down to -5, then all of our values, our parabola, every single value has shifted down 3.5. So this value here has moved, sorry, not 3.5, has shifted down 5 because our k value is -5. So here, instead of being at 4, it's shifted all the way down and now it's at -1. And so every single one of our parabola points has been moved down negative. It's been moved down 5. So our formula is y equals x squared minus 5. So our k value is -5 and our parabola moves down 5 units. So k value is called a vertical shift. That is what the basis, that's what the transformation is called. And if we have a positive k value, we shift our whole parabola up by that value. And if we have a negative k value, then we shift our whole parabola down by that value. And that's how it works. Shifting it up or down based on how much the k value is. So let's do some practice problems. So we're going to state how the parabola shifts and what the k value is for each of these equations. So A is y equals 4 times x minus 3 quantity squared plus 6. Now we've got a lot of stuff going on and we didn't look at this. And so we have to remember that our k value is our number that is at the end. Doesn't matter if we have other numbers in there. It's our number that was being added or subtracted on at the end. So for this question, k equals +6. So that means that are we moving up or down? If it's positive, that means that we're shifting up 6 units. All right, part B, y equals -x plus 25 all squared plus 100. Again, it doesn't matter what these other numbers are going on. We're just looking at this at the end. It doesn't have to be at the end. It usually is, but it's what we're adding outside of the brackets. So k is equal to plus 100. Okay, well, if it's positive, then we're shifting up. And the number 100 is how many units we do it. We're shifting up 100 units. C equals y, for number C, for letter C, y equals x minus 17 squared minus 42. Again, we're looking at this value outside of the brackets is our k value. So k equals -42. So it's negative this time. So that means that we are shifting down. And it's 42 units. And letter D, y equals -1 times x plus 5 quantity squared minus 50. Our k value is this minus 50. So it is negative. So again, we are shifting down, this time by 50 units. And that's how we can identify our k value in a parabola, is that we're always looking at this number that is outside of the brackets. And we're looking at the sign too. The sign tells us if it's up or down. All right, so practice problem 2, graph the following functions. So we're going to look at y equals x squared plus 5. Well, remember, for this, we think about our parent function, which you'll get used to knowing. Mine is not perfect. It's really hard to draw these perfectly, particularly on a computer screen. But it's roughly this, though it's totally, sorry. I'm just going to draw this new one because I'm having a really hard time getting it properly. You can just sketch these and it's okay if it's not perfect. So for y equals x squared plus 5, we know that we're shifting up. Our k value is equal to plus 5. So we're shifting up 5 units. So instead of being at 0, 0, we're going to be at 0, 5. And instead of being at 1, 1, we're going to be at 1, 6. Instead of being at 2, 4, we're going to shift up to 9. Instead of being at 4, 16, we're going to shift that 4 up to 21. And the same thing on the reverse. Once you do the positives, you can kind of just go with and look at the negatives and make it symmetrical. Now, this should be a really smooth curve. As you can see, it is not, because it is hard to draw. When you're doing it by hand, you can turn your paper around and you can use the curve of your hand, and that can work really well. But again, it's about the idea. It's okay that it's not perfect. It's key to label your graph so that you know, and that I know, what it is that we're talking about. So y equals x squared plus 5 has shifted up 5. Y equals x squared minus 7, because it's minus 7, k is equal to negative 7. So we're shifting down 7 units. So the same thing, 0, 0 is now going to be 0, 7. 1, 1, we're going to shift down to be 1, negative 6. 2, 4 is going to be 2, negative 3. 3, 9 is going to be 3, 2. 4, 16 is going to be 4, 9. So these numbers I know in my head. You can use the a table of values, or you can also draw your parent function, which is what I was hoping to do, but because I'm bad at drawing on here, I didn't. And then you can move each point down by 7 units for this particular question. And there we go. Now we've sketched that graph. All right, so we have run out of time and we have lots left to do. So we're going to finish the rest of our lesson in our next class. So if you have any questions or concerns, please reach and contact me. All of my contact information is in your booklet, and it was at the beginning of our lesson. So give me a call or send me an email or connect with me on Facebook, and we can go through again this part. And again, we will review it a little bit tomorrow when we, or in our next class, when we go complete lesson 1. Thank you so much for joining me. I hope you have a lovely day, and Miigwech.